Good afternoon. Good afternoon, everybody. Welcome to the DTE Studio lecture on database management system. Myself, I am Dr. Vijay Kalmani. I'm principal of Jain Polytechnic. My specialization is computer science. This is my second lecture on DBMS. Well, yesterday we just started with the introduction of database management system. I just want to quickly wrap up that what did we study yesterday. Well, database is nothing but a collection of related records. Data means known facts that can be recorded and have implicit meaning. For example, consider the names, telephone numbers, address of the people. Now, this data can be recorded in an indexed address book or can be stored it on a hard drive using a personal computer or a software such as an Excel or a Microsoft Access. Well, database management system. Now, it is a collection of programs that enable users to create and maintain a database. The DBMS is a general purpose software system that facilitates the process of defining, constructing, manipulating, and sharing of databases among various users and applications. Well, defining a database involves specifying the data types, structures, and constraints of the data to be stored in the database. In C language, whenever you are declaring any variable, you are declaring the type of the variable, the value it is going to hold, etc. The same way, these rules also apply here. The database definition or descriptive information is also stored by the DBMS in the form of database catalog or dictionary, and this is called as the metadata. Well, I'll just start sharing the screen. So the outline, this is the outline. Yesterday we did see some basic definitions. I don't want to again repeat it. We saw a simplified database system environment where you have the metadata or the stored database at the bottom and the database software in the middle level, where you are storing, where you are writing queries or programs on the stored database. And at the upper level, you have the application programs interfaced to the users. Well, today we will see an example of university environment, a mini world for the example. Consider a simple example university database for maintaining information concerning students, courses, and grades in university environment. Now, the database here is organized as 4 files. I'll just show you. The course, the section, the grade report, and the prerequisite. Well, the database, as I said, is organized into 4 files. Student file stores data on each student. Course file stores data on each courses. Section, that is the section file, this stores data on each section of the course to which section it is being offered. Grade report files stores grades that students receive, various sections they have completed. And prerequisite file stores the prerequisites of each course. To define this database, First you should specify the structure of records of each file by specifying different types of data elements to be stored in each record. So in the above database, each student record includes data represented as student's name, number, class and major. Each course includes course name, course number, credit hours, and the department to which the course is being, by which department the course is going to be offered. Data type of each element within record should also be maintained. For example, student name is of alphabet. So data manipulating involves querying and updating. Now, examples of queries like, suppose you want to take out or retrieve the list of all courses and grade of Smith, then you need to write a query for that. You want to list the names of students who took database course and their grades. So these are queries. For this, you write SQL statements, that is structured query language statements. Now, update is nothing but, suppose you want to change the major of Smith. Say Smith has taken computer science, you want to change him from computer science to EC. So that is updation. Well, we will now look on to the main characteristics of this database approach. The first characteristic, self-describing nature of a database system. A fundamental characteristics of this database approach is that the database system contains not only the database itself, but also a complete definition or description of the database structure and constraints. So the DBMS catalog stores the description of a particular database, data structure, types, and constraints. Now this definition is stored in the DBMS catalog. The information stored in the catalog is called the metadata. The catalog is used by the DBMS software and also by the database users who need the information about the database structure. So this is the self-describing nature of a database system. The second characteristic is insulation between programs and data. In traditional file processing, the structure of data files is embedded in the application program. So any changes to the structure of a file may require changing all programs that access that file. The structure of data files is stored in the DBMS catalog separately from the access programs, and this property is called program data independence. In some types of database systems such as object-oriented and object relational systems, users can redefine or can define operations on data as part of the database definitions. An operation, also called as a function or a method, it again is defined or specified in two parts, categorized into two parts: the interface or signature, the first part. Second one is the implementation or the method. This interface or signature of an operation includes the operation name and the data types of its arguments, that is the parameters, and the implementation of the method of the operation is specified separately and can be changed without affecting the interface. Well, user application programs can operate on the data by invoking these operations through their names and arguments, regardless of how the operations are implemented. And this may be termed as program operation independence. Well, the third characteristic, so this is one simplified database catalog where you have, I said in my first characteristic, the relationship name, the relation name, and the number of columns they're having, and the data type of each column name. For example, student number here is of character type, which is of width 4, and other column names. Data abstraction. We continue with this next slide, that is the data abstraction. Well, a data model is used to hide the storage details and present the users with a conceptual view of the database. So a view, now what is a view then? A view may be a subset of the database, or it may contain virtual data that is derived from the database file, but it is not explicitly stored. Multiple user DBMS whose users have a variety of distinct applications must provide facilities for defining multiple views. Support of multiple views of the data. So each user may see a different view of the database, which describes only the data of interest of that user. So the database, the DBMS must include concurrency control software to ensure that several users trying to update the same data do so in a controlled manner so that the result of the updates are correct. For example, when several reservation agents are trying to assign a seat on an airline flight or a railway, so DBMS software should ensure that each seat can be accessed by only one agent at a time to a passenger. And these type of applications are generally called online transaction processing, OLTP applications. So here the OLTP application is a major part of the database application. Well, then we come to the database users. Well, users may be divided into, or who are these users? They are actually use and control the database content, and those who design, develop, and maintain this database application are called actors on the screen. So who control the content, who design, develop, they are nothing but the actors. And who design and develop the DBMS software and related tools are called workers behind the scene. So who are the actors on the scene now then? The database administrators. See, in a database environment, the primary resource is the database itself, and the secondary resource is the DBMS and related software. So administrating these resources is the responsibility of the database administrator, or also called as a DBA. He is also called as a DBA. So The DBA is responsible for authorizing access to the database, coordinating and monitoring its use, and acquiring software and hardware resources as needed. So DBA professionals are also highly paid in the industry today, in many of these industries. So the DBA is accountable for problems such as security breaches and poor system response time. So there's a lot of role of this DBA in maintaining the DBMS software. So in large organization, the DBA is assisted by a staff that carries out these functions. They have assistant DBAs or they have technical supports, etc. Then the database designers. So he is also on the front side of the DBMS scene. Well, database designers are responsible for identifying the data to be stored in the database and for choosing appropriate structures to represent and store this data. It is the responsibility of these database designers to communicate with all prospective database users in order to understand their requirements and create a design that meets these requirements. Database designers typically interact with each potential group of users and develop views of the database that meets the data and processing requirements of these groups. So you have a team, a software team who is working on database. It is the designers who will help in designing the structure or the content of this DBMS. Now, each view is then analyzed and integrated with the views of other groups, and the final database design must be capable of supporting the requirement of all users. The end users. Now, who are these end users? They are the people whose jobs require access to the database for querying, updating, and generating reports. The database primarily exists for their use. Now, there are several categories of end users. We have casual end users. We have naive or parametric end users. We have sophisticated end users, standalone end users. Just to summarize, who are these casual end users? Casual end users occasionally access the database, but they may need different information each time. They use sophisticated database query language to specify their requests and are typically middle or high-level managers or other occasional browsers. The naive or the parametric end users. Their main job function involves around constantly querying and updating the database using standard types of queries and updates called canned transactions. So, example are bank tellers or reservation clerks who do this activity for the entire shift of operations. Now, the sophisticated end users. These include engineers, scientists, business analysts, and others thoroughly familiarize themselves with the facilities of the DBMS in order to implement their own application to meet, you can say, their complex requirements. Then who are these standalone users? These are the people who maintain personal database by using ready-made program packages that provide easy to use menu-based or graphic-based interfaces. An example of this is a tax program that creates its own internal database, and another one is an address book or a CD catalog. You have compact CDs, your songs, etc. Well, now what are these advantages of before I go to the advantages, I would like to also tell in brief about the workers behind the scene. Now, these workers behind the scenes are the users who design and develop the DBMS software and related tools and computer system operators. So these are called workers behind the scene. So DBMS system designers, these are the person who design and implement the DBMS modules and interface as a software package, whereas tool developers, they are the people who design and implement tools, the software packages that facilitate database modeling and design, database system design and improved performances. And the system administration personnel, also called as the operators and maintenance, who are actually responsible for the actual running and maintenance of the hardware and software environment of the database system. Well, advantages of using the DBMS approach. First one is the controlling the redundancy. See, what happens is in database approach, the views of different user groups are integrated during database design. And ideally, we should have a database design that stores each logical data item, such as student name or his birthplace, in only one place in the database. Now, this is known as data normalization. We'll come across this in the further chapters. And it ensures consistency and saves storage space. So redundancy is minimized. However, it is sometimes necessary to use controlled redundancy to improve performance of queries. If you have multiple data stored on multiple different tables, unnecessarily duplication of data takes place and it becomes difficult for the queries to execute. Second advantage is restricting unauthorized access. So when multiple users share large database, it is likely that most users will not be authorized to access all information in the database. Consider an example here, like a financial data. Now, the financial data is often considered confidential by companies or organizations, and only authorized persons are allowed to access the data. In addition, some users may only be permitted to retrieve data, whereas others are allowed to retrieve and update the data. Retrieve means just to see. They can just filter out the data or just go through the data. Updation is not possible. You cannot add or delete anything there. So there are different types of users who have different types of access operations. Okay. The third advantage is providing persistent storage for program objects. So, this is covered in chapter 20 or 22 of your textbook elsewhere in Navate, Fundamentals of Database Management System, Navate. Database can be used to provide persistent storage for program objects and data structures. The values of program variables or objects are discarded once the program terminates, unless the programmer explicitly stores them in a permanent file, which involves converting these complex structures into a format suitable for file storage. So when the need arises to read these type of data once more, the programmer must convert from the file format to the program variable or object structure. So object-oriented database systems are compatible with programming languages such as C++, Java, and even Python. So hence, a complex object, for example, in C++, can be stored permanently in an object-oriented database system. So such an object is said to be persistent since it survives the termination of program execution and uh, can be later directly retrieved by another C++ program. So persistent storage is to store the data for a longer time. Now, the fourth advantage is providing storage structure for and search techniques for efficient query processing. Because when you say indexing, means indexing is for searching. It builds up uh, efficient searching capabilities. So the database system must provide capabilities for efficiently executing queries and updates. Because the database is typically stored on the disk, the DBMS software must provide specialized data structure and search techniques to speed up disk search for the desired records. Because see, when you say database, it's a huge collection of records. Amazon like website maintains data of millions of users. So auxiliary files called indexes are used for this purpose. And the query processing and optimization module of this DBMS is responsible for choosing an efficient query execution plan for each query based on the existing storage structures. Another example is providing backup and recovery services, providing multiple user interfaces, representing complex relationships among data. So I don't want to go providing backup and recovery services. Yes, every database system should have a constant, good backup and recovery services. Representing complex relationship among data. Yes, I'll touch on this. A database must include numerous varieties of data that are interrelated in many ways. So a DBMS must have the capability to represent a variety of complex relationships among the data to define new relationships that as they arrive and retrieve and updates related to the data easily and efficiently. Of course, the next advantage is the enforcing integrity constraints on the database. So, most database applications have certain integrity constraints that must hold for the data. So, a DBMS should provide capabilities for defining and enforcing these constraints, and the simplest way of integrity constraint involves specifying a data type for each data item. So you store, for example, the student name, you should have the type defined for the student name. That is, you define it as a character. So it will be stored in character. You may sometimes, or the student register number. So the constraint here is it should be unique. No other student on the in the database should have the same register number, right? So some constraints can be specified to the database and automatically enforced. Other constraints have to be checked by update programs or at the time of data entry. Well, now there are some implications of using database approach. Potential for enforcing standards. This is very crucial for the database applications in large organizations. Reduced application development time. So incremental time to add each new application is reduced. Flexibility to change data structures, availability of current information, economics of scale. Something we will see like the historical development of database technology. Well, early database applications using hierarchical and network systems. Many early database applications maintained records in large organizations such as university, hospitals, and banks. And in these applications, there were large number of records of similar structure. So there were many interrelations among these records. One of the main problem was the intermixing of the relationships. And another shortcoming of this system, these type of systems, was they provided only programming language interface. This made it more time consuming and expensive to implement. This was the drawback. Some of the early, that is in mids or in the early 1960s. Providing application flexibility with relation databases, object-oriented applications, and need for the more complex database. So the emergence, of object-oriented management systems, programming language in 1980s, and need to store and share the complex structured objects led to the development of what we call today object-oriented database management systems. Initially, these object-oriented database management systems were considered a computational to relational database since they provided more general data structure. Now, they were mainly used in specialized applications such as engineering design, CAD, that is CAD, multimedia publishing, etc. Interchanging data on web for e-commerce. Users here can create documents using hypertext markup language HTML and store these documents in web. Documents can be linked through hyperlinks. So slowly the HTML, XML data, were extended markup language. These were all considered to be the primary standard for interchanging data among various databases and web pages. So new functionalities now is being added to DBMS in the following areas. These are all that is scientific applications, XML, image storage and management, audio and video data management, data warehousing and data mining, spatial data management, time series and historical data mining. Now, when not to use a DBMS? In spite of the advantages of using a DBMS, there are few situations in which a DBMS may involve unnecessary overhead costs that could not be incurred in traditional file processing. The overhead costs of using a database are also of due to some things like high initial investment in hardware, software, and training. The generally that a DBMS provides for defining and processing data, overhead for providing generalities, security, currency control, recovery, and integrity function. So some of these are the reasons for overhead, costs. Therefore, it must be more desirable to use regular files under the following circumstances. So when a DBMS may be unnecessary, you can say. Simple, well-defined database applications that are not expected to change at all. Okay. If there are stringent real-time requirements that may not be met because of DBMS overhead. Embedded systems with limited storage capacity where a general purpose DBMS could not fit. No multiple user access to data. So these are the instances where a DBMS may be unnecessary. So to summarize with this types of databases and database applications, so we did see different types of database and applications, some basic definitions, functionalities. We also saw some database example, that is a university database, characteristics of database approaches, users, both actors in front of the screen and behind the screen, advantages of using the database approach and when not to use the databases. Well, before I go to the part 2 of the first chapter, I just want, if anybody wishes to ask any question. So I'll stop sharing the screen now.